Hello, this is an Algebra 1 video. It is Chapter 6, Section 6. It is the last section in the chapter, and therefore you will have a test coming soon. So today we're talking about systems of inequalities. Obviously the entire chapter has been about systems of equations, and this time we're going to be talking about systems of inequalities. The good news about a system of inequalities is that you don't have to find the exact point where the two lines cross when you graph them. You're looking for a whole region of solutions. So I'm going to show you how to do that, but again, since you already know how to graph lines, this should not be very complicated. So the first thing you want to do is get a coordinate plane up here. And we will do that like right so. And the first line says y greater than negative 2x plus 1, which tells us that this line is going to be a not solid line, but a dashed line. So, and we're going to shade and all that goodness, but aside from that, it's y equals mx plus b, which means we're going to put our y-intercept 1, 2, 3, 4. Let's go 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I don't know why I'm counting like that, but it sounded like fun. So here's your plus 1. And since the slope is negative 2, we're going to go down 2 over 1. Or you can go up 2 over 1. And we're going to draw our line, but when we do so, we're not going to make it solid. We're going to make it dashed. Yay, it worked. Like so. You can test the origin to see which side you're supposed to shade. And it's going to be, if I test the origin, I'm going to put 0 in the y spot, 0 in the x spot. So my statement will read 0 greater than 1. And 0 is not greater than 1, so I don't want to shade the side that the origin is on. I'm going to shade the other side. But because I have to shade the area where both lines cross, I'm not going to shade it just yet. I'm just going to draw arrows indicating that I'm going to shade in that direction. So then we're going to go ahead and graph the next line. That one's going to be solid because it has an equal to. So we are going to take plus 3, 1, 2, 3, my intercept. And then we're going to have a sort of 1. So we're going to go up 1 over 1 or down 1 over 1. And we're going to graph the line this direction. Just like so. And then again, we're going to test the origin. So we're going to put a 0 in the y spot, our symbol, and then we put a 0 in the x spot. So our statement will read 0 is less than or equal to 3, and 0 is less than 3. So we're going to shade towards the origin. And again, I'm just drawing my arrows there. And then when I actually do my shading, I want to shade the area where the arrows are facing each other. Okay, so basically up in the, there's 4 regions. You've got a region up here, down here, and over here. So when I look at this region, I only have 1 arrow in this area. The other arrow is going the opposite direction. So we don't want to shade there. Over here you don't have any arrows facing over here. In this region you've got the red arrow but no blue arrow. And over here is where you have the red and the blue combined. And that's the actual solution to the system. So we shade this little guy over here. And so with inequalities, instead of getting just one solution point, you end up with all of these points that are in this yellow area that all represent solutions to the system. So that is how you do that. So now we're going to let you go on to this example here. Do it yourself. And there's the second part of do it yourself. There's A, B, C, and D. And then we're going to do another example. And this is an example of basically what happens when you have no solution, because we already know that we can have parallel lines. Sometimes the regions never cross, but the majority of the process is the same as before. We need to have a coordinate plane. X. Looking like a good little Spanish lesson for you. Y. And we are going to graph this little guy. And these are both in standard forms, so I'm going to put them in mx plus b. So let's see here. We're going to get negative y for the first one, greater than or equal to, and this 3x is going to go to the other side as a negative 3x, plus 2. And when I divide by the negative, I'm going to get a less than symbol because I have to flip my symbol, a positive 3x, and a minus 2. So there's my first equation. And my second one is going to be much like it. We're going to go negative y less than, and then the negative 3x is going to go over here, minus the 5. We divide by negative 1. And when you divide by negative, the little symbol flips, and I get 3x plus 5. So there's my second equation in mx plus b. So the first one's going to be 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so 3x minus 2. So you're going to be down here at negative 2. And your slope is 3. So you're going to go up 1, up 2, up 3, and over 1. Or down 1, down 2, down 3, over 1, either way. And this little guy happens to be solid. So we're going to graph our line like so. And then as far as shading, we have the origin over here. So we're going to pick 0 for y, less than or equal to. And if I plug in a 0, then we have negative 2. Is 0 smaller than negative 2? No, 0 is not smaller than negative 2. So we're not going to shade toward the origin. We're going to shade away from the origin. And then we're going to graph the other line. And it has the same slope, but it has a different y-intercept. So we're going to go 1, 2, 3, 4, 5, so up here somewhere off my graph there. Then I'm going to go up 3 over 1. As you can see, I have no space to go up and to the right. So I'm going to choose to go down 1, 2, 3, and to the right. More like so. Okay, so we're going to, oops, and this line's supposed to be dashed. And you can tell that my graph is very not accurate, but it will suffice for what I want to show you. Because these lines are supposed to be parallel. And as you look at them, they don't look very parallel. That's because my graph is off. But it will help us. We're going to figure out what we're going to shade, right? So here it says greater than, so we're going to put in a 0 for y. Is 0 bigger than 5? No. That's false. So you don't shade towards the origin, you shade away from the origin. And see what's going to happen is both lines are being shaded away from the origin. And they're parallel, so they're never going to cross. And so you're going to end up with a region that's shaded. Yeah, there we go. I wanted my highlighter. You're going to have all this region over here on this side. And then you're going to shade all this region over here on this side. Now remember, these lines are supposed to be parallel, so they're never going to cross. And you can tell they're parallel because their equations have the same slope. So, and what's going to happen is that there's no overlap in the regions. Therefore, there is no solution for this particular system. No solución. Yay. Okay? So now we're going to let you try these two little guys. And I think we have one more example, and then we can call it a day. All right. So here in our last example, we have a word problem. And it says, I don't even know where this name came from. It's the weirdest name. I've never heard it in my life. If you have that name, I'm so sorry. It says Monifa. Not Monica. I don't know how you say it. Is it Monifa? Monifa? Whatever. It's a weird, I think it's typo, but that's the bell, sorry. But anyway, Monifa, whatever her name is running for student council. The election rules say that for the election to be valid, at least 80% of the 900 students must vote. Monifa knows that she needs more than 330 votes to win. So that's our situation. So it says define the variables and write a system of inequalities to represent this situation, and then graph the system. So the graph part's going to be over there on the right, but we are going to define our variables, and I've already got x and y over there. So we got to give definitions for x and y. So we're going to let x be the number of votes required, number votes needed or required. And then we're going to do Y is going to be the number of votes that she needs to win, that Monifa needs to win. Okay? So it says, we go back and read here, it says, the election rules say that for the election to be valid, 80%, at least 80% of 900 students must vote. So we need to calculate what 80% of 900 is. So 900 times 0.8 is 720. So we know that X has to be at least, so greater than or equal to 720. And then we have that for the other part, we know that the number of votes that Monifa needs to win is 330 because she told us that over there. So Y has to be greater than 330. Not equal to, it needs to be greater than 330. So to solve this little system, it's not going to be very complicated.
Yes.
I am recording, so I'm sure that these people are not going to be talking anymore. So now, when you graph these equations, they're actually pretty easy to graph because you don't have to have two variables in the equation. Remember that when you only have one variable in the equation, this is a vertical line and this is a horizontal line. So on the x-axis, we need to find where 720 is. And so 720 here, we're going by 1, 2, 3, 4, 5, 6, 700, this is 800. So somewhere pretty close to the 700 line, we're going to place a vertical line that basically represents that x's have to be larger than that line. So we're going to be shading in this direction. And then for the horizontal, we have to find 330 on the y-axis. And again, the x variable is missing here, so that's how we know it's a horizontal line. And this is 300, this is 400, so it's not quite 350, so a little bit below that. And of course, it's not going to be exact, but you'll get the gist. And I got to keep my line going over here. Like so, and that line should have actually been dashed, so let me adjust that real quick. Let's try that again. Like so, and you want to be above that barrier. So you can already see that the overlap in those two regions is going to be here. But we also need one more thing, a couple more graphs that we need to put in here. Actually, I probably shouldn't have done that yet. We also know that there's only 900 students. So when I say that the line's going to go forever, that's not really true either. We need to put another barrier at, this is a 7, 8, 900. So another vertical line needs to go right here down at the 900 situation, because we don't have more than 900 students, so it wouldn't make sense to have students in the 1,000 mark or the 15,000 mark, okay? So we know that we have less than 900 students, or at most 900 students, and now we're in between these two areas. And since there are only 900 students, as far as voting, you're also going to have 900 going across this way. This is 800, 900, so I'm going to put this guy over here, and you want to be less than that direction. So at the very end of the day, we end up with this little rectangle right here as our solution area. Okay, so just keep in mind why we put the 900 there. If only 900 students are there, then only 900 votes can happen. It wouldn't make sense to have 910 votes if there's only 900 students. No one can vote twice. So that's why there's a cutoff at 900 on the y-axis, and there's also a cutoff at 900 on the x-axis. So you get a little rectangle. And then it says, name one viable option. That's easy to do. All you have to do is find one point that would find itself in this area. So for example, you could, 800 is in between these two. So we can say 800, and this is 500. So this point right there, well, let's not have the highlighter on. So 800, and then what did I say, 500? That point right there is a viable option. 800 students voting, and 500 of those voting for Monifa would be one viable option. There are obviously many others, but that would be one. Okay, so that's how you do that. And so now I'm going to let you do this last do-it-yourself question. Once you have completed this question, you will have completed your notes for this lesson. And I will see you in class, and thank you for watching.